Hello everyone. In this second part, we're going to see how to calculate some of the chain rules directly over some function. So there are two different approaches that we can take when calculating chain rule directly over a function, and is trying to decompose this into the inner and the outer function. So for example, here we have g of x equals 9 sine of 1 plus 3x minus 1. And so I can kind of see g as h compose f of x, right? So I need to figure out who h and who f of x is. So in this case, I can say, well, f of x is going to be what is inside of the function. That makes it complicated. So f of x will be 1 plus 3x. And then h of x will be 9 sine of x minus 1. Okay. Once that you identify those functions, then you can verify, yeah, the combination of 9 sine of f of x minus 1 will be 9 sine of 1 plus 3x minus 1. So the advantage of working in this way is that you can do the derivative separately. So for example, you can do f prime of x is just 3, and h prime of x is going to be 9 cosine of x. And so because of that, then you can apply chain rule in the chain rule formula, and g prime of x will be h prime compose f of x times f prime of x. And so using what h prime is, this will be 9 cosine of f of x times f prime of x. And then finally we can just replace by what f of x and f prime of x are. So in this case will be 9 cosine of 1 plus 3x times 3. Okay. So that is one approximation to that, which require identifying who's the inner and the outer function. The other thing that you can do is just do it directly. We already did this in class, so I'm gonna, and we have a different version of the solutions. So I'm going to go ahead and just do this one as you will do when you're already an expert on doing chain rule. So in here, notice that this is a power. The big function is a power that is encompassing this stuff that is inside. So in here, if I take the derivative, the big thing is the power. So I'm going to put down the exponent. So this is 7 times minus 4 times, and so it's going to be the same thing. And then I'm going to subtract 1 here because it's a power. So minus 4 minus 1. Okay? And so in here, so far, I'm only doing the derivative of the power. But now I got to multiply by the function, the derivative of the function inside. And what is that? In this case, is the derivative of x to the 4 plus 3 squared of x. So that will be 4x to the 3 plus 3 times 1 over 2 squared of x. And so simplifying this, this will be minus 28 x to the 4. I'm using inconsistent notation. I should use a point to do the multiplication so you don't get confused with the times. This will be x to the 4, 3 squared of x, and so this will be power to the minus 5. And then times 4x to the 3 plus 3 over 2 squared of x. So it pretty much depends of which technique you want to use. If you want to use this one or do you want to use this one, all's fine, but just depend of your mileage with this. Now number 3, again, is something that at this point you can do either with product rule or with in product rule and chain rule, which is how we're going to do it now. We're going to express this as 100 times 1 plus 15 e2 minus w And so that will be to the minus 1 because we're putting this denominator up. Okay, so this is a chain rule because now it's a power to the something, and there is something inside. So that's why it's a chain rule. Now f prime of w here then will be, we put down the minus 1, so it becomes minus 100, and then we leave the function the same, but we subtract 1 here, so minus 2, and then now we multiply by the derivative of the function inside, which would be 0 plus 15 e to the minus w times minus 1. Remember, this is e to the kw, so the derivative is e to the kw times k, but k in this case is minus 1. Alright, so this is one way of doing this, but now since you know the product rule and the quotient rule, then you can also do this with those rules. Okay, and you can get a similar result doing it that way. If I simplify this out, notice that this is a minus. So this minus is going to be minus 15 here. And with this one is going to be plus. So this is going to be like 1500 e to the minus w. And then 1 plus 15 e to the minus w minus 2. That will be the simplification of this. And what I mean of doing this by product rule is, of course, you can do this as a product rule of 100 with this term as well, but that can be more complicated in this scenario. So for now, I'm just gonna leave it that way. Now moving on to the next one, we have an exponential here. And so you know that what we're doing with chain rule is essentially we're just trying to see this as a simplified version of a more complicated function. So notice that this is e to the something, but we can just call this e to the f of x, right? And so if b is e to the f of x, b prime, what is it? Then it's e to the f of x times f prime of x. That is what the chain rule is. We're doing the derivative of e to the f of x is e to the f of x, same thing, but we gotta multiply by the derivative of the function that is inside. So hopefully that's gonna be a different approach from what we also have in the solution. That is, I'm doing it with the outside function and the e to the stuff. And so in this way you can have two different ways of seeing this. Now if now we just say what this is e to the 15 x squared minus cosine of x plus the square root of x, so same thing. And what if f prime? So f prime is 30x minus, and the derivative of cosine is minus sign, so plus sign, and then plus 1 over 2 square root of x. So this will be the derivative in this scenario. Notice that technique that I just applied of seeing a complicated chain rule as just the derivative of a simple function composed with another one also works for this scenario. I can see this h of x as log of f of x, and so if I see it that way, h prime is just going to be the derivative of log, which is 1 over x, but composed with f of x, so 1 over f of x times f prime of x. Okay? And so now at this point I can replace what f of x is. And I can multiply by the derivative of f of x, which is 10x to the 4 plus 6x. And that's it. Now number 6 is 4 times 2x plus cosine of x to the 2/3. Again, I can see this as 4 f of x power to the 2/3, right? So it's a power, again, the main derivative. So g prime of x is going to be what? It's going to be, I put down the 2/3, so 4 times 2/3 f of x 2/3 minus 1 times, and so the derivative, I need to multiply by the derivative of the function inside, f prime of x, and so this is 8/3. And now I can replace what f of x is, which is 2x plus cosine of x. Notice that 2/3 minus 1 is going to be minus 1/3. Okay? Since 1 can be seen as 3/3, and 2/3 minus 3/3 will be minus 1/3. Now, f prime. F prime will be the derivative of 2x, which is 2, and the derivative of cosine, which is going to be minus sine. And that's it. This is the derivative for this particular function. Now, let's move to 7. And so again, another way of seeing this is as a certain function f of x power to the 7. And so if r of x is f of x power to the 7, r prime of x is 7 f of x power to the 6, since I'm subtracting 1 here, times the derivative of the inside, so f prime of x. Now at this point, I can actually go back and write what f of x is, and then multiply by the derivative. Remember that the derivative of an exponential of this type is itself times the log of the base. So b to the x, the derivative is b to the x times log of b. So in this case, that will be 3 to the x, log of 3, the derivative of 1 is 0. So this is the end result here. We can simplify a little bit this out. This is 14 log of 3 times 3 to the x times 2 times 3 to the x plus 1 power to the 6. Following this logic, number 8 is also the sine of a function f of x. And so b prime of x would be the cosine of f of x times f prime of x, the derivative of the inside. We go back and say, well, what is the inside function f? 6 squared minus x cubed, so the derivative of that one is 2x minus 3x squared. That's it. On number 9, notice that we have this as a quotient. So now you can do it with the quotient rule, or this is another way of thinking of the product rule, the quotient rule. But you can also do it by rearranging this function as 2 plus 3 log of x to the minus 1. Okay? And so once that you do that, this is again a function f of x to the minus 1. And so what is y prime? Y prime will be minus 1 f of x to the minus 2 times f prime of x. But who is f again? So now we write what f is. And we write what the derivative is. So in this scenario, 2 becomes a 0, and log of x is going to become 1 over x, so this becomes 3 over x. All right. So for the next one, we have an exponential, but it's an exponential to another function. So notice that this is the same that having a function from the type b to the f of x. That will be the case that we're working here. So let's arrange it in that way. This is 1.02, and that's going to be our b. 1.02 to a certain function f of x. So if we follow that logic, g prime of t is just going to be the same thing because it's an exponential. 1.02 to the f of x times the log of 1.02 since again, remember, if we have a b to the f of x, that will be the derivative will be the same thing but by log of b, and then of course by f prime of x. So that's what's happening in here. We have log of 1.02 times f prime of x. Now we worry about who f of x is. So this is 1.02 to the cosine of x times the log of 1.02, that is a number. And if f is cosine, then f prime is minus sine of x. And so we can rearrange this at the end as minus log of 1.02 sine of x times 1.02 power to the cosine of x. Number 11 can be also seen as sine of a function f of x. Clearly the function f of x is e to the minus 3x, and so y prime is cosine of f of x times f prime of x. In this scenario, we get back to what f of x is, which is e to the minus 3x, and then f prime is going to be the derivative of e to the minus 3x, so e to the minus 3x times 3 times minus 3. Okay, so simplifying, this is e minus 3 e to the minus 3x cosine of e to the minus 3x. Now number 12 has a little bit more work because it's a sum of multiple functions. And each of them is going to be potentially having their own chain rule. So you can kind of split this apart between this function and this function. Okay. So if I'm saying that y1 is e to the q cube, then I'm saying that this is e to certain function f of x. Then what is y1 prime? The derivative of that is going to be e to the f of x times f prime of x. Who's f here? Q to the 3. So that means that I can rewrite now the derivative. E to the q to the 3 times 3q squared. On the other hand, if I have that y2 is minus 5 log of q squared minus 3q plus 5, then I can see this, and notice that I'm not changing anything yet, as minus 5 the log of certain function g of x plus 5. And so now if I take derivative, is a simple derivative, and this is just minus 5. The derivative of the log of g of x will be 1 over g, but I gotta multiply by the derivative of g, and the derivative of phi is 0. So now I can come back and say, well, what is g? So in this case, g is q squared minus 3 cubed. And so the derivative of that is going to be 2q minus 3. Simplifying that, this is 10q minus 15 over q squared minus 3q. And finally, I can rearrange then the whole solution. And so h prime of q will be the sum of these two things. E to the q3, 3q squared, plus, and then, oh, I have a minus here. This will be minus 10q plus 15 over q squared minus 3q. And that is one of the most complicated cases here, where we have multiple chain rules and we're combining with the law of the sum, which is the derivative of a sum is the sum of the derivatives. Now, to finish up this video, we have the tables. So notice that in this table I've been given values of x, f of x, and f prime of x, and x, g of x, and g prime of x. So I just gotta play with the formula here and find out what they're telling me to find. So in A, I have the derivative with respect to x of f of g of x, which is just f prime in g of 1 times g prime of 1. So we're using the chain ruling here. So what I need to do is find who g of 1 is. And in this case, it's easy. When x is equals 1, g is 6. So this will be f prime of 6 times g prime of 1. So now I can care about the derivative. F prime of 6. So I step on x equals 6 and take a look at what happened to f prime. F prime in that scenario is minus 4. And now g prime of 1, I step on 1, and what is g prime? 0.1. And that's it. So I multiply here, and this will be minus 0.4. Now this second one is another way of talking about the derivative, the chain rule. Why? Notice that this symbol is a composition. Okay, so this f composed g prime of 3 is still talking about f prime of g of 3 times g prime of 3. So it's similar to the one that we just completed. So what is g of 3? G of 3 is going to be 3. So this becomes f prime of 3. And now I gotta find out who is f prime of 3 and g prime of 3. So f prime of 3 is gonna be minus 1. And g prime of 3 is gonna be minus 0.4. So this actually becomes positive 0.4. Now, here we have the same way of asking this. We're asking the same thing in a different way. We have h is f composed g. What is h prime of 6? So h prime here is going to be f prime composed g of x times g prime of x, right? And if I'm asking in 6, then h prime of 6 will be f prime of g of 6 times g prime of 6. Now, what is g of 6? So if I step on g and go to 6, I find out that g of 6 is 1. So this becomes f prime of 1. In g prime of 6, oh, wait a minute. Yeah. In f prime of 1, yeah, times g prime of 6. And now what is f prime of 1? F prime of 1 is 2. And g prime of 6 is going to be 0.3. So this will be 0.6. Now I can do the same thing, but I can talk about the reverse order. So I'm doing here mostly f compose g, but there's nothing that says that I cannot do g compose f. So if I follow this rule here, this is going to be g prime. This derivative here is going to be g prime of f2 times f prime of 2. Just following the chain rule here. Now that you know how this is done, f of 2 is 1, so this is really g prime of 1 times f prime of 2. And I gotta find out each of this. G prime of 1 is 0.1, and f prime of 2 is 1. So this is 0.1. And g compose f prime of 4, again, this is g prime of f of 4 times f prime of 4. What is f of 4? F of 4 is going to be 4. So this becomes g prime of 4 times f prime of 4. F prime of 4 is going to be minus 2. G prime of 4 is going to be 0.7. So this is minus 1.4. Okay, and so here's the end of the video. I'll see you in part 3.